sun takes center stage as a life-giving force for our planet. However, like all stars, our sun is not eternal, and its destiny holds a dramatic transformation known as the red giant phase. Surprisingly, scientific speculation suggests that the Earth could endure the sun's red giant phase. But could Earth, against all odds, truly survive this transformation? What if there were a different perspective to consider? Join us as we explore the resilience of Earth in the face of the sun's impending transformation. An overview of the sun's future. To gain a comprehensive understanding of Earth's potential survival during the sun's red giant phase, let's explore what scientists predict for the sun's future over the next few billion years, simplifying the concept to represent its entire life cycle. You see, the journey begins with a cloud from the distant past, condensing into the present-day solar system. Eventually, the sun will transform back into a cloud, leaving behind a white dwarf. Before this change, the sun will enter a phase called a red giant, resembling Betelgeuse, but smaller and less massive. This phase is anticipated to start in approximately 5 billion years. However, the specifics of the sun's evolution during this process remain unclear due to the limited examples of stars like the sun at various stages of their life. Obtaining more examples is crucial to unlocking the mysteries of the sun's transformation. It is currently assumed that during the red giant phase, the sun will grow to about 200 times its current size and shed some mass, contributing to the formation of planetary nebulae across the galaxy, similar to the well-known Helix Nebula. These nebulae are crafted by expanding red giant stars as they lose mass, continuing to shape the sun's destiny over billions of years even after the red giant phase. To grasp the entirety of this process, it is essential to delve into various instances of similar stars at different stages of their lifespan. Over the last decade, numerous intriguing discoveries have surfaced, providing substantial evidence to support many assumptions regarding various star systems. One particularly notable observation stems from a distant star situated more than 10,000 light-years away. In this instance, scientists made an unprecedented red nova observation, suggesting a collision with another celestial body, potentially a star. The implications of this finding align remarkably well with our comprehension of the life cycle of stars, particularly when a red giant star engulfs one of its planets. This discovery significantly bolsters our existing knowledge about planets close to stars that eventually evolve into red giants. The confirmation of such predictions underscores the progress achieved in our exploration of the cosmos and the validation of theoretical frameworks developed over the years. Rho Coronae Borealis and our sun's future. In the broader context, studying stars in different stages of their life helps us put together the puzzle of how the universe works. By looking at different examples, we learn about the processes that control how stars are born, live, and eventually die. These discoveries not only help us understand more about space science, but also add to the overall knowledge that shapes our understanding of the cosmos. The fact that we can make these observations from extremely far away, like over 10,000 light-years, shows how much progress we've made in technology and observation methods for studying space. These far-off views of the universe give us important information to improve existing theories and create new ones, making our understanding of the universe even better. The question that naturally followed was, what will happen to our solar system? When contemplating our solar system's fate, the prevailing assumption is that our sun will either shrink to a size slightly smaller than Earth's orbit or potentially expand almost to the orbit of Mars. However, the challenge lies in determining the amount of mass the sun will lose over time, leading to uncertainty. To address this uncertainty, scientists look to other star systems with similar mass and properties for comparison. Rho Coronae Borealis, a star system with a comparable mass and size to our sun, becomes particularly interesting in this context. What adds to its intrigue is the presence of 4 planets in orbits that closely resemble those of Mercury, Venus, Earth and Mars in our solar system. This comparative analysis aids researchers in gaining insights into the potential future of our solar system. Rho Coronae Borealis stands out due to its age, estimated to be between 9 and 10 billion years old. This unique feature provides scientists with an opportunity to study and potentially calculate the mass loss in stars similar to our Sun. The goal is to gain insights into the eventual transformation of our Sun into a red giant by examining comparable star systems. Essentially, Rho Coronae Borealis serves as a representation of our Sun in the phase just before it evolves into a red giant. In an interesting simulation of this star system, 4 planets were observed closely orbiting the star. Notably, the closest planet in the simulation is already changing its atmosphere, rapidly evaporating due to the star's transformation. By meticulously modeling the star and predicting its evolution over the next 2 billion years, the primary research uncovered the most likely fate of these planets. Importantly, these findings extend beyond the distant star system and offer insights that can be applied to understand the future of our planet, Earth. If you're curious about the specifics, let's break it down. The nearest planet in this star system is about 3.8 times the mass of Earth. Moving on, the second planet has a mass similar to Jupiter, and the last 2 planets share striking similarities with Neptune. Now, looking ahead over the next billion years, an interesting fate awaits these planets. They are all set to gradually disappear, with 3 of the inner planets likely to be completely swallowed by the evolving star. The gradual disappearance of planets. Each planet's demise will unfold in slightly different ways. The innermost rocky planet, for example, is expected to undergo a process of complete evaporation. Although it may sound rapid, this disappearance will likely take a few hundred years. The intense heat from the star will impact the planet's surface, causing materials like silicates to transform into vapor. Eventually, these vaporized elements will be blown away by the stellar winds. In the larger picture, within a few hundred or maybe 1,000 years, the innermost planet will vanish. A similar fate is predicted for Mercury, the planet closest to our Sun in our solar system. Moving on to Jupiter, it faces a distinct cosmic destiny characterized by tidal disruption, similar to the process that formed Saturn's rings. Unlike a catastrophic event, this subtle force is expected to shape Jupiter's fate. It's crucial to emphasize the magnitude of this celestial drama, as we're not discussing the fate of a mere moon, but an entire planet. In contrast, our cosmic history introduces an intriguing celestial body, Hala, which shares similarities with Jupiter in terms of mass. Despite being engulfed by its host star, Hala's survival offers a glimmer of hope for our current planetary subject. While optimism surrounds its potential survival, for analytical purposes, we'll maintain the assumption of eventual destruction. A parallel fate may unfold for the third planet, but our focus shifts to the 4th planet in this cosmic narrative. Completing its orbit in 282 days, akin to Venus, this planet stands at the precipice of defying cosmic odds, boasting a high probability of survival. As the host star undergoes expansion, shedding mass in the process, an intriguing interplay of forces takes place. The gravitational pull on the 4th planet weakens slightly, leading to an extension of its orbit. Gradually distancing itself from the impending cosmic turmoil, there's optimism that the planet will resist disintegration, even if it may eventually face engulfment by the star's outer layers over several thousand years. The cosmic metamorphosis of a resilient planet. In the vast dance of the cosmos, the 4th planet stands out as a potential survivor. As the star contracts, the planet might emerge, carrying remnants of its celestial interaction. The expected loss of a significant part of its atmosphere during this cosmic encounter could set the stage for a transformative journey. After this cosmic dance, the 4th planet is ready for a metamorphosis. By shedding layers of its atmosphere in the cosmic exchange, it has the potential to transform into a different celestial body. This transformation could lead to the emergence of a super-Earth or a transition into a terrestrial planet, signifying a profound shift in its cosmic identity. Despite the complex dynamics involved in the red giant stage, marked by repeated cycles of contraction and expansion, the fate of this specific planet remains a captivating cosmic enigma. The potential engulfment it may undergo multiple times during this stage raises the prospect of its remnants orbiting at much greater distances. There's even the intriguing possibility that its orbit could align closely with that of our planet Earth. As the star goes through repeated cycles of shrinking, remnants of this planet could end up orbiting at a distance similar to Earth's path in space. This raises the idea that during these cosmic changes, the planet might turn into a terrestrial entity like Earth. The researcher suggests that this transformation could provide insights into the future of our home planet. This leads to the interesting idea that Earth might undergo a similar cosmic journey. The envisioned scenario involves a celestial dance where the planet brushes the sun's surface for thousands of years before gradually moving away, reflecting the potential fate of our planet. Alternatively, there's the intriguing possibility of a temporary plunge into the sun, only to emerge later as a slightly altered celestial body. A glimpse into Earth's future transformation. In this cosmic story, Earth's destiny unfolds as a tale of transformation. The expected loss of surface crust and the acquisition of new elements during these celestial encounters would make the future Earth different from its current state. The planet we are familiar with today may go through a metamorphosis, offering a glimpse into the ever-changing nature of celestial bodies and their dynamic journeys through the cosmos. When the sun completes its life cycle and transforms into a white dwarf, a process commonly observed in other large dying stars, it follows a predictable pattern seen in similar star systems. Scientists have observed the existence of planets around white dwarfs, some of which may be undergoing similar changes, while some planets in wide orbits around these white dwarfs appear swollen or transformed into ring-like structures. There are documented cases where white dwarfs have planets in the habitable zone, where liquid water could potentially exist. Studying a solar system similar to ours, which consists of a sun-like star and 4 planets, provides valuable insights into what might happen to Earth throughout billions or even trillions of years. The possibility of survival, transformation, and eventually orbiting around a white dwarf for an extended period becomes apparent. However, the fate of planets around a black dwarf, the subsequent stage after a white dwarf, remains uncertain. At this point, gravitational interactions may cause many planets to become rogue, drifting through interstellar space in isolation. Do you think that Earth could survive the sun's red giant phase? Let us know your thoughts in the comments below. Thank you for watching. See you in the next update.